BE and CF are two equal altitudes of a triangle ABC. Using RHS congruency rule, prove that the triangle ABC is an isosceles triangle. So I would like you guys to draw the diagram on your own, write what is given and what is to be proved. So till there you guys have to pause and think over. So remember, have your diagrams, have your opinion. It's important for learning. That's the whole point of recorded content. You can always pause and think over. You can take your own time. Right? Now, let's think about the diagram. So since they're talking about isosceles triangle, let's draw an isosceles triangle. Okay, looks good enough. Then we have okay, ABC. So we have altitude to this. Altitude will be okay. I think I would like to redraw this. That's better, right? Altitude will be no. I want to have a diagram wherein the altitude is easy to look at. Okay, I think this will help. So this is your altitude over here, right? Good. And that will be your altitude. Okay, so ABC. See, this is how you think. I tried few ways, then I got a better diagram. Not that those would have been wrong. Those would have been tough to think. That's it. So we have this. Okay. So they are equal. So we just have to prove that this is an isosceles triangle. So quite a few ways you can prove it. Prove two sides are equal, if not two angles are equal. So we need to, okay, we have been given that BE is equal to CF. Then BE is an altitude. So what can you conclude? This implies angle BEA is equal to 90 degree. Then the next thing that is given is CF is an altitude. This implies angle CEA is 90 degree. Then by RHS congruency rule, prove that triangle ABC is isosceles. Okay. So to prove triangle ABC is isosceles. Now we have the proof. So how do we go about? We can, okay, no, I want you guys to think, right? That's the whole point. Think over. We have to use RHS. So the main thing over here is considering triangles. Which triangle should we consider? Well, we can consider triangle BCF and okay, let me redraw this. Not particularly happy. Yeah, that'll be better. And over here we have okay, right? So this is my BCF and this is BCE, right? So these are our triangles. So what is that we are looking at? BC is equal to BC, 190 degree. This is the hypotenuse, is it not? And we need one side. Well, the side is also given. We have the altitudes which are equal. So by RHS, these two are congruent, and so angle B is equal to angle C, and thus we have this entire thing to be an isosceles triangle. So consider triangle BFC and triangle BCE. BC is common. Then we have angle BEA, which is equal to CFA, and they are 90°. And we have the third side, PE is equal to FC. So pretty much all these are given. So what can you tell? Therefore, by RHS congruency, triangle BCF is congruent to triangle BCE. This implies angle CBF is equal to angle BCE. Okay, so basically I just told that this particular angle is equal to this particular angle, and so those two angles are equal, and thus the triangle is an isosceles triangle. Therefore, triangle ABC is an isosceles triangle as two angles are equal. Okay, hence proved. So pause and have a look. See how the separate diagram makes things very clear. Looking at this, it's not so easy. So especially when you have angles to deal with, it's better to draw such diagrams. Right? So have a look at this. Again, this need not be this neat. I just happened to draw it neat because I wanted 90°. Actually, it depends on my mind. I was not even thinking of 90°. Anyways, this is must to draw neat, right? This is optional to draw neat.